Hello, everybody. We have got Dr. Lindsay Broadbent with us today. Thank you very much for coming and chatting to me, Lindsay. So this is part of the International Women's Day conversations with female scientists with the Science Room. And Lindsay is going to come and chat to us today then about her experiences of being a woman working in STEM subjects. So Lindsay is a virologist in Queen's University, Belfast. You probably will have heard Lindsay on the radio, if not seen her on TV or read something that she's been saying lately, particularly with a lot of the COVID research that Lindsay has been working on. But more generally, Lindsay works on respiratory viruses and the long-term consequences of people who are ill with respiratory viruses. So Lindsay, could you tell us then a little bit more about what got you involved in working in this kind of field in respiratory viruses in particular?
So I've always had a love for science, and we can talk about how I got into that if you want, but the respiratory side of it really came from when I started my PhD. I started working on a virus that every single person in the world has had, but no one has ever heard of, and it's a virus called RSV. And again, everyone listening to this will have had RSV at some point in their life, but they probably don't know about it. It can cause very, very severe illness in young children, and it can lead to the development or certainly help in the development of asthma. So it's obviously a major issue, especially for kids. Because I have so much experience with respiratory viruses, when 2020 came along and COVID kind of hit the world, I was very well placed to kind of be seconded to work on COVID. So we paused all of our other respiratory virus work and straight away shifted to COVID and trying to figure out why COVID was making people sick, why COVID was making some people sicker than other people, and also can we try and find a treatment for COVID. So that work is still going on. I think COVID work will go on for years to come, unfortunately, but it's very interesting. And I think viruses are one of the most interesting things you can work on. Granted, they've got a bit of a bad rep in the last few years, but they are such an interesting, cool part of science to research.
So what then got you kind of involved in science then? Kind of what's been your pathway to get here?
So I think probably like a lot of people when they're in school, you hear about the typical careers, do you want to be a teacher? Do you want to be a lawyer? Do you want to be a doctor? And I think if you're pretty good at science, the typical response is, hey, you should apply for medicine. So I did. I applied for medicine. I had a few offers to go and do medicine at university. But when I was in kind of lower sixth, upper sixth, I really struggled with my mental health. And my A-level results were just not what they needed to be. I think I disappointed everyone when I got my A-level results, or certainly that's what it felt like. So I knew I wanted to be involved in science. So I started doing a biomedical science degree, and I thought if I do this degree, then I can go from this degree to do medicine, because I didn't have the grades I needed. And then as soon as I started biomed, I realized, you know what, it's not the healthcare part of medicine I was interested in, it was the science part. And so I kept doing the science part. I got so into the cell biology and the genetics and the hematology lectures, like they were what I loved. It wasn't necessarily the learning about the human disease side, it was the, wow, how do we research this? I had the opportunity during my undergraduate degree to go and work in a hospital lab running all the clinical samples. And I realized as well that that wasn't really what I wanted. So I got involved with lab research, and I found my thing. I found what I love to do. And that's when I started to apply for PhDs. And I'm so grateful I did. And there's a phrase my mum uses all the time. It's a very Northern Irish phrase: what's for you won't go by you. And I think that things have worked out the way they were meant to. I'm not sure I'd have made a particularly good medical doctor, but I think I'm not bad at the science doctoring. So yeah, it's been an interesting road, one that I didn't plan, but one I am incredibly grateful to be on.
Brilliant. Yeah, it's never straightforward. Sometimes that keeps it even more interesting. So what skills and qualifications then? So obviously you'll need your university qualifications, but what kind of other skills as well do you think are particularly useful in your field?
My job is weird. Like being a scientist is bizarre. Like one day I'm planning experiments and I'm doing math calculations and figuring out how to plan something. And the next day I'm changing bulbs and fixing freezers and doing stock takes and figuring out what we have to order. So you're kind of a bit of a jack of all trades.
Mhm.
And it's not as pure intellectual, I think, as a lot of people assume. It's a very practical job. You have to have so much common sense. You have to be able to plan, you have to be able to organize, and you have to be able to communicate. Like one thing that scientists do and should do is communicate their work to other people. And whether that's, going on the news to talk about COVID, or even just within your science group, within your research group, talking about what you're doing.
Mhm.
Communication is a massive skill, and it's one that we should be learning really from a pretty young age, in how to communicate what we're working on or what we're learning with other people. So I think certainly for me, communication is the biggest one, but there are so many that I think if I started trying to list the skills that you need and the skills you learn, we'd be here all day.
Yeah, agreed. So with that then, what would be the best aspects of your job, and then what would you find the most challenging as well?
Ooh, I think the most challenging is you're doing something completely new. There isn't a framework to follow. There's not a textbook you can open and go like, okay, I follow this and things will work out fine. There's a lot of failure in science. You can set up an experiment, there's no guarantee it will work. You
Mhm.
could plan an entire research project and there's no guarantee it will work, because you are the first person doing that, and possibly in the world for the first time. And while I say that's a downside and it's quite a scary thing, it is also one of the advantages, because if it works, you're also the first person in the world that has seen that experiment work. You are the first person to find this thing, and that's amazing. And those moments don't happen often in a career, but they do happen, and when they do, they are incredibly valuable, just personally, not for your necessarily for your career, but as a scientist, those are the moments I think we all try and aim for.
Mhm.
For me as well, apart from the science, I love working with a group of people that we can all kind of decide what we're doing. It's so collaborative, that you work as part of a team, but
Mhm.
within that, you're responsible for your bit of that project.
Mhm.
So it's a really nice mix of being able to work on your thing, but working really closely with other people. And working closely with other people that you can share ideas with, you can get advice from. It's fantastic. And it's not even just within your research center, but even globally. We collaborate with people. Like at the minute, I'm involved with a project. We have collaborators in Australia, in London, in Scotland, in Ireland. We collaborate globally, and you get to meet and you get to travel and you get to experience things, I think, that a lot of careers don't offer.
Mhm. Yeah, definitely. Super. So how then, you mentioned whenever things fail and obviously experiments don't always work, um, how have you managed then with setbacks? Because it happens to everyone at some stage, and maybe lots and lots and lots of times to some people as well. So how do you kind of cope with those
Yeah.
setbacks?
This is probably awful advice, but you do get used to it.
Mhm.
And no one likes to hear that, because it's like, oh, you'll get used to it, it's fine. Uh, but it is partly true. And I think, the more you realize that it's not a be all and end all, like your career is not based on this one thing failing. It never is. You have opportunities to correct it. And I would always say to the students I have, to the PhD students, the undergrad students, if you fail and you learn something from that failure, then it's not a failure. The only time it's actually a failure is when you don't learn something from it. Like otherwise, it is always useful. It is always something to build on. And you do that experiment again and you change the thing that didn't work. And then hopefully this time it will work. So no, failure is a fantastic learning opportunity. In science, we try to avoid the word failure. It's just an experiment that didn't work and you try it again. Yeah, it does take a while to get your head around it. It does take a while to come to terms with, hey, that failed and that's okay, without having to, you know, go home early and buy a pint of Ben and Jerry's on the way home. But it does come. It does come.
Yeah, get the Ben and Jerry's to celebrate it when it does work. You need
Exactly.
a lot less of it probably. So any words of wisdom then for young people, and in particularly given that it's International Women's Day, for young girls who are thinking about entering STEM subjects?
You can do it. I think there's a lot out there to say people can't, or if you haven't been, you know, academically minded in school, you can't do that. You know, it's an academic career. That's not true. This is a practical career. This is a career that relies on common sense. And if science is what you want to do, you can do it. Everyone that starts a PhD in our lab, I always have a wee chat with them and say, listen, I think anybody can do a PhD. It's about attitude. It's not about intelligence. It is about your commitment to science. It is about how you approach something. Anyone can read a paper and learn something. Anyone can follow a recipe or a protocol, but it's about your attitude and your want to be a scientist. And if you have that, then you will succeed.
Yeah, very true. And then lastly, this year's theme for International Women's Day is break the bias. And there's all sorts of bias across all fields, but we do have plenty of it in STEM. Plenty of it is kind of well documented and trying to kind of increase the amount of women entering STEM subjects. But obviously bias isn't necessarily just gender based, it kind of goes across the spectrum. But where do you find there are opportunities then to break that bias in your field?
Things have gotten a lot better. So I think we have to start with that. Comparing now to even 5, 10, 15 years ago, the number of women in science has gone up. The equality in science is getting better. Representation is getting so much better. But there is still a ways to go. You know, even when you look at where I'm currently based in my centre, the number of women in senior management roles, in senior research roles, is the vast minority compared to the number of men. But I think when it comes to this, I always like to quote Jocelyn Bell Burnell, who is a fellow alumni of Queen's. She was an astrophysicist that was quite frankly robbed of the Nobel Prize. And I may be paraphrasing slightly, but she said that people from different backgrounds approach a problem in a different way and address questions in a different way. And I think that is so important to science. We need people from different backgrounds, from different walks of life, different life experiences, because they approach science in different ways. And we don't just want one aspect, one person's interpretation of science. We need that from everybody. And I think if we remember that, then I'd like to think that senior management is getting better and that we are getting a more rounded view of what science should be. So yeah, I will continue to encourage people to get into science. I will continue to encourage people from all walks of life to get into science. And if anyone ever needs some virology work experience, let me know.
Brilliant. Work experience is key. Absolutely. So thank you very much, Lindsay. I'm sure you'll be inundated probably at some stage now. So all the best with the rest of the research and with your new job coming up in Surrey. And hopefully we'll get chatting to you again soon. Thank you.